Hi guys, and welcome to another video of my channel. In this video, we will do a deep dive into the architecture on AWS for Craft CMS. Now, Craft CMS is a growing and already very popular CMS, which is a very viable alternative to other popular CMS like WordPress and Drupal. So, a couple of things to note about Craft CMS before we start looking into this beautiful architecture diagram that you see on your screen is that Craft CMS is based on PHP programming language, and it is built using the Yi PHP framework. In terms of the networking part of our architecture, it's pretty standard. We are going to have our own separate VPC, and we are going to have multiple private subnets and multiple public subnets, at least two. This architecture diagram assumes two. And everything would be in the private subnet, you can see, besides the our load balancer. This is going to be our publicly facing endpoint. Here's a better version of the circle that I wanted to draw initially to basically include all the resources that are supposed to be in the private subnet. Now, in terms of other technology decisions, I'm just going to go to the next slide and then come back to it. I will keep doing that. For each slide, I will come back to this diagram to visually represent our decisions and our architecture. So our main technology choices are Amazon ECS for container orchestration, RDS Postgres for as the database server, Secrets Manager to store all the secrets as well as the environment that would get exported to the Craft application when it would run within the container. And the base Craft images we are inheriting from this location. Within this image, you have Nginx and Alpine Linux as the OS. Okay. So now coming back to the diagram again, you are seeing that there is an ECS service. We are using ECR or container image repo. And here you see tasks in a different AZ for the application. And here we are depicting the secrets manager. First challenge when you are designing a PHP or actually any application, any web application in a load balance environment is how are you going to manage sessions? Specifically in terms of PHP applications, if they are using PHP for session management, then we need to have a solution for that because by default, PHP sessions are file based, which means that they are stored locally in the on the server or container which the application is being run on. So in a load balance environment, when your requests are being routed to multiple instances, this approach is not going to work and you are going to have a very bad user experience and users would keep getting logged out and any other implication associated with session data not being available on the other server, users would have to bear the consequences of those issues. So there are multiple solutions for this problem. The solution in our design that we are going with is we are just going to use sticky sessions with the ALB. And what it does is it basically establishes affinity between user and the server. So each user's request is going to get routed to the same server. So this way we are not going to run into any session issues because although the session data is being stored locally on the server, since that user is always getting routed through on the same server, we are not going to have this issue. Other possibly scalable solutions are we could use a Redis cache, which obviously is better than using a database, which is disk based, whereas Redis or mem cached instance would be memory based. We could use these solutions for session storage, or we could even have a EFS volume that we can mount and use that as the destination to store session data, and we could adjust that using this PHP INI parameter. Next problem we are going to look into is the issue of assets. Uploaded files like images, PDFs, any other documents which you can upload to Craft are stored on the local file storage by default in Craft. So in a multi-server environment, how do we manage it? There are multiple solutions to that. The one solution that we have picked is using an EFS file system. It probably may not be, one can argue that it's may not be the best solution. The best solution might be to use S3, but it's definitely a viable solution. And we are going ahead with this because of actually my bias towards this solution that I've used in the production deployments that we have done for Craft. So as I said, we are going to use EFS file system, and then we are going to mount the file system to under, we are going to create another folder called assets. By the way, this presentation is assuming that Craft, when we install Craft, when we deploy Craft on the containers, it gets deployed under the app folder inside the container. So anyway, we are going to create another folder called assets, and then we are going to mount the EFS volume in under assets. Now, newer versions of Craft have introduced some abstraction in terms of your file system and then the volume. So you are going to create a Craft file system and then associate it with this EFS volume that you have mounted. And then now you can create one or more volumes using this Craft file system that you have associated with app assets directory. So any volume that you create using this Craft file system, this would be available to all server instances. As I mentioned, the other solutions are we can use S3 or any other cloud-based storage provided by other cloud providers. So now if we go back to our diagram, we can see that we have this EFS created, and then we have the EFS mount targets in each subnet, and then these are getting mounted. And here's the path that I mentioned. Okay. Another problem to solve in a load balanced Craft CMS environment is the problem of cache. Just like PHP sessions, Craft uses the local storage for the cache, and we need to come up with a solution which needs to support the distributed nature of the deployment that we are doing on the cloud. So for that, we are simply going with the database-based caching solution, and we would need to make a code change for this in the config section of the application. And other possible solutions are to use memcache. And I don't have this mentioned, but you can also use EFS for caching as well. How are we going to centrally manage and export all the environment variables which needs to get exported to Craft? For that, obviously, we need to use a centralized secrets storage solution. The reason why I'm saying secrets is because some of those environment variables also contain sensitive information. So we need to store this data with encryption. We need to have versioning, and we need to have all the checks and balances that are required for storing sensitive data. We have multiple options here. The one that we have gone with for in this architecture is AWS Secrets Manager. Could also use the SSM parameter store, another AWS service for secrets and parameters as well. And we can also go with a third-party solution like Doppler, but for this specific solution, we are going with Secrets Manager. Obviously, when you use a native AWS-based solution, it comes with its benefits, one of them being that it has tight integration with the rest of the AWS ecosystem. It's very easy to import secrets from Secrets Manager in a cache definition. You can also retrieve secrets from the container instance by using AWS CLI commands. So all of that integration we get for free since we are using an AWS native solution. So now we're going to go back to the diagram and see where this part is represented in the diagram. So here is the secrets manager, and it has a link to the task. It's actually this instance that it's linked to. Okay. Now I want to go back to the slide for this because one thing that an important thing to mention here is this part, right? So in the container entry point or the command script that runs when the container comes up, we want to make sure that we source the environment entries from secrets manager so that when the application comes up, it can view, it has access to the environment variables so that when the application comes up, it has those environment variables exported for it to retrieve. Another problem that needs to be addressed is how are we going to pass the same security key to each instance, container instance of Craft. The solution at this point is pretty obvious since we have already discussed our centralized solution to store the Craft environment, which is using the AWS Secrets Manager. So all we need to do is just define this variable in the Secrets Manager entry, and then the process that we discussed in the previous slide is going to ensure that this environment variable also gets exported when the Craft server comes up. A very important problem to address is how are we going to manage the project config. The project config files that are YAML files which are generated by Craft, they are stored in the local file system. So in order to manage this in a distributed architecture, we first need to disable admin changes using this config parameter. Okay. And then any config change that we want to make should be made through the local development environments. And then the files should be committed to our source code repository. And then during deployment, we need to run the craft up command to ensure that the latest config changes are getting applied. Another very important problem to solve here is logging. There are two main categories of logs that need to be captured in centralized log storing service. We're going to use CloudWatch for this. First is this std out and std error. The reason why we need these is because due to the container image, the base container image we are using. In that image, Nginx server access logs are outputted to std out and std error. So we need a solution to send these to CloudWatch. Also, Craft stores application logs to under storage logs folder. So we need a way to send these logs to the centralized log service as well. So to send the std out and std error logs, all we need to do is just use the AWS log driver with our containers, and that is going to take care of pushing the std out and std error logs to CloudWatch. But we need a custom solution for publishing the logs that are stored in the storage logs folder. For that, the solution that we are going with is to spin up another container, which we are calling the log sidecar container, along with the ECS tasks. And this container's job would be to push any log files, any log data that is stored in this folder to CloudWatch. The solution for this is to create a Docker volume and then mount it on the Craft server as well as the sidecar container, and then configure CloudWatch agent on the log sidecar container to publish these logs to CloudWatch. Okay, so let's go to the diagram and get a better understanding of how this would be implemented. Okay, So here you are seeing the ECS task, and then this is the main Craft CMS container, the web server, and this is the sidecar, the log sidecar container, which has CloudWatch agent installed. Actually, we are just using the image, the CloudWatch agent image for this container. So we don't need to do any installation ourselves. When the container comes up, it already has CloudWatch agent installed. And all we need to do is just provide the CloudWatch agent config through an environment variable that would allow it to push the logs in this directory to CloudWatch. Okay, so here we are depicting that there is a Docker volume. It's not an EFS volume because it's just this volume is just being shared with these two containers within the same task. So we don't need an EFS volume for this. We are just going to use the task definition to create this Docker volume and then mount the volume on both containers. For the Craft application, we are using this path to mount, which is the default storage path for logs. And then for the log sidecar container, we are mounting it here, but we can select any location. But we'll just have to go and update the agent config to point to the location that we select. Okay, and then this is going to ensure that any application level logs which Craft generates gets published to CloudWatch. So these are all the challenges that we need to address in order to deploy Craft in a load balanced environment on AWS. I'm just gonna go over a couple of things that I don't have slides for, and one of that is our database. You can see in the diagram, we have our RDS PostgreSQL instance. And since this is a production setup, I am going with a multi-AZ setup. And here you're seeing that there is a standby instance for our database. Also, these are the technologies we are using for our pipeline. So standard AWS CI/CD services. There you have it, guys. This is a production grade, secure, scalable Craft CMS architecture that you can use to deploy Craft CMS on AWS. Thank you for watching this video. And if you have any questions, please feel free to ask them in the comment section below and I will respond. And if you like the content, please make sure that you subscribe to the channel. Thank you. Bye.